I am Mini from EC department. Now I am going to explain the topic LED, that is light emitting diode. What is light emitting diode? Actually it's a diode. When the diode is forward biased, it emits light, which is called light emitting diode. This LED is a two-terminal semiconductor device which converts the electrical energy directly into light through electroluminescence. What is electroluminescence? It's the principle of LED, that is light produced by electricity. That is what electroluminescence. So this is the symbolic representation of LED. I already told that it's actually a diode. If it emits light, we can say that is a light emitting diode. Okay. Then next, construction. How to construct this LED? We use one base material or supporting material. We can say that is a substrate. See the diagram. So that is what substrate. In that substrate, we form three semiconductor layers. One of the layer is P-type, that means holes are present in that region, and another one type is N, which have electrons present in that region. Between P and N region, one of the region which is active region, that region is responsible for the emission of light. Okay, so this light will be emitted not only the single direction, it will emit all the way around the layered structure. The whole structure is placed in a tiny reflective cup that we see in the figures B, that is small reflective cup. What is the purpose of this reflective cup? If we used this reflective cup, the light gets reflected towards the desired exit direction. Okay, so that's why we used this cup, which this whole layered structure which is present inside that. Okay, then next principle. The principle of LED is what? Electroluminescence. That means it's the phenomenon in which a material which emits light when an electric current or voltage is applied. Okay, so simply we say that light produced by the electricity. Then working, how to work this by using the LED. When a PN junction is forward biased, that is the electrons present in the N region that will cross the junction and recombine with holes which is present in the P region. Normally the free electrons reach this band. They are not lightly bound. That's why we will say that the electrons are free. The holes exist in the valence band. What about the energy level? That energy level is higher than when compared to the holes of the energy level. Okay. Then if the electrons recombine with holes, what happened? While moving from conduction band to valence band, that is from higher band to lower energy level, the additional energy is released. That additional energy appears in the form of light. Why? Because means we constructed the special material used in the LED. Okay. So practically, if the LED is forward biased, the holes from P region and the electrons from N region enter the active region. This active region is placed between P and N. In this active region, the recombination of electrons and holes takes place. No, so the energy is released, that is in the form of light. Okay, so between the conduction band and valence band, in between there is one energy level is there. We can say that is forbidden gap. That forbidden gap determines the wavelength or color of the emitted light. Okay. Then one of the characteristics of this LED is internal quantum efficiency. Efficiency we will denote that as eta. How to define that internal quantum efficiency? It's defined as the ratio of number of photons generated to the number of electrons injected. So this internal quantum efficiency will occur inside the active region. Okay. Then next one is external quantum efficiency. Here from the name itself we will understand external means it will outside, that is from the LED to the number of electrons injected. We can define the definition. It's defined as the ratio of number of photons emitted to the number of electrons injected. Okay, so what are the materials used in LED? Normally we are used gallium or silicon, but here we are used only gallium arsenide, gallium phosphide, gallium arsenide phosphide. If we used gallium arsenide, the color is invisible. We can say it is infrared light. Then if it is gallium phosphide, red or green color is visible. Then gallium arsenide phosphide means the color will be red or yellow. Then output characteristics, the output is, the power of the output will be translated into light. That is proportional to the forward current. If the current increases, the output light will be greater one. So see the diagram. This is the output characteristics. In x-axis we used current in milliamps, then y-axis power. So the current increases, the power will be increases, it will reflected as light. Then advantages, so many advantages of present in this LED. It's very low cost and long lifetime. It's available in different colors, but it is operated at very low voltage also. But disadvantages, it's frequent replacement of battery, because if we used low power battery, that time frequently we will replace the battery. It's one of the disadvantage. And its luminous efficiency of LED is low. Sometimes its characteristics will be affected by the temperature. When we operate this LED, we need the large power. These are the disadvantages of LED. What are the real applications we used in real time or daily life? That is used in watches and calculators. Then remote controls, burglar alarms, and sometimes we used in optical devices also. We can say that is optocouplers. These are about LED. Thank you.